So September 2021, we can begin there. And the question says, question 1A says, the Aviation Perspectives Agency recently conducted a market survey to determine the air travel preferences of 170 travelers in a certain country. The air travel preferences were presented by the following airlines: Excellent Airways, Safari Connections, and Tumaini Services. The following results were obtained from the survey. So we are given all that. And now we are asked to get a Venn diagram. So that is now question 1. Question 1. We are told to get Roman 1 Venn diagram. So the Venn diagram is drawn like this. Draw 3 circles. Then you label them. The first one is called excellent. The second one is called Safari. The third one is called Tumaini. So this is A, B, C, D, E, F, G, H. So when you have it that way, N is the total number of travelers, which you are told is 170. Then here we shall bring our answers. That should add to 170. So from there, we now bring the equations. And the equations are designed as per the explanation here. We are told that 100 travelers preferred excellent. So everyone who is inside excellent will be equal to 100, or total will be 100. That is A plus B plus C plus D. Those are the people who are inside excellent. 40 are preferring Safari. So Safari, we talk of 40 being equal to B plus C plus F plus G. Then from there, we have 75 who preferred Tumaini. So 75 is equals to C plus D plus E plus F 20, they preferred excellent and Safari. So excellent and Safari, where they intersect, we have BC. So 20 is B plus C. 28, they preferred excellent and Tumaini. So excellent and Tumaini, that is CB. That is 28. C plus B. Excellent and Tumaini. 18, they preferred Safari and Tumaini. So Safari and Tumaini is CF. Those are 18. The C plus F. 9 travelers did not record any preference. So those who did not record any, they are H. So 9 is equal to H. And then finally, you bring the whole equation. The whole equation says 170 should be equal to A plus B plus C plus D plus E plus F plus G plus H. So that is what we call the whole equation. Then from there, you begin your workings. You begin your workings. And as you begin your workings, you start by checking whether there is any value that is already well known. And such, the first is 9, that is H. So you run here and record 9. So this H has helped us. Then you check where you have H again. And when we look for H, we come and find it here. It is together with those others. So those others, we check who is already known. And in checking that, we realize that A, B, C, D, they are already known. They are already known. So we are left with E, F, G to find out. And in so doing, we can get assisted from here. Now that CB here is known because of this 28, then we are able to say that EF is known. So if we are able to say that EF is known, then we are just left with G to look for it. So G then will be equal to 170. You minus this block, which is 100. You minus this other block, which is 75, minus 28. Then you minus H. H is 9. H is 9. So we have 170 minus 100 minus 75 plus 28 minus 9. That gives us 14. So that tells you that G is 14. So we have been assisted by this equation. So we mark it out that way. Then we look for G, where else we can find it, and it is here. And where we find it, it is together with C. So that means we can be able to say that F is equal to 40 minus BC. BC is 20. Then you minus G, which you have gotten as 14. So this then must become 6. So F is 6. F is 6. Now, if F is 6, this equation has assisted us, and we are grateful. Then we can come to this one, which can help us look for E, because we already know F. So that we say 75 minus CD, CD is 28, minus F, which is 6, should be equal to, if you seek help from your calc, you get 75 minus 28 minus 6 is 41. So E is 41. So this one has assisted us there, and that is great. Now we come back here, and when we get there, we already know F. So we are able to say that C should be 18 minus F, which is 6, and the answer is 12. So C is 12. And if C is 12, we proceed, this one has assisted, so we come here where we say that D should be equal to 28 minus 12, and that is 16. So D is 16, that way. Then we have B here, we have B, so B will be equal to 20 minus 12, that is 8. That is 8 because of C there. Then we get up there, we get A. A is going to be 100 minus B, which is 8, minus 12, and minus 16. So you have 64. Huh? 16 is wrong. D. See, D was 16. We are looking for A. So I'm saying 100 minus 8 minus 12 minus 16 is 64. Then, if you're not very sure, or just for purposes of confirmation, you add these values to check whether they go back to 170. So if you say plus 8, plus 12, plus 16, plus 41, plus 6, plus 14, plus 9 is equals to exactly 170. So that means we are okay. So that is the first answer to the requirement of the question. And with that, we proceed and seek the next answer. Determine the number of travelers who preferred all the three. So Roman 2 is those who preferred all the three. All the three. So those who preferred all the three, they must be C, and C is 12. And C is 12. The number of travelers who preferred the Safari connections and Tumaini, but not excellent. So those who preferred Safari and Tumaini, Safari and Tumaini, but not excellent. But not excellent. So those who preferred Safari and Tumaini, it is C and F. C plus F. But we are told that they must not touch. Excellent. So of these two, whoever touches excellent is going to be left out. So the excellent is touched by C. So this one we leave it out, and therefore we say it's just 6. F is 6. F is 6. So we are now through with that. We are through with that. And we therefore go to part B of the question that says the following data presents the quarterly inputs of electrical products by a certain electronics company for the given year, for the given 4-year period. Now, using a 4-quarter moving average, calculate the seasonal variations from the above data, and then you derive the seasonalized data using the additive model. We are still in question 1, part B of it. So we are looking for analysis sheet. Analysis sheet. And we are using the additive model. The additive model, which is A is equals to T plus S plus E. So we will have a column here for the year, a column for the quarter, a column for the imports, a column for the 4 moving averages, a column for the centered, a column for the so here we have the year, here we have the quarter, here we have imports, here we have the 4 moving average, the 4 moving average. Then here we have centered average, centered average. Then here we have seasonal variation, seasonal variations. And these seasonal variations, we have the estimates, and we have the accurate. Then here we have the seasonalized. The seasonalized values. In terms of initials, imports are A, centered they are T. This one is A minus T. This is S. And this one is A minus S. A minus S. So we are supposed to begin at the year 2017. And we said you record these values and you skip one line. So 1, 2, 3, 4, 1. This is 2018. 2, 3. So I skip, I say 4. This is 2019. 2, 3. So that means I still have so 4, that is then 1, this is 2020, 2, 3. So my space is not enough. We can pack a 4. So 4, 1, that is 2019, 2, 3, 4, 1, that is 2020, 2, 3. Oh, so I just actually needed just 1. 4. So from there, we record these values. The values are 43, 71, 83, 59. We have 50. We have 50. We have 82. We have 93. We have 75. 62. 89. 101. 81. 73. 95. 120, and I need to remove this one. It's a bit congested. So this is 4, which is 89. So we start getting the moving averages, 4 moving averages, and remember we said you take the first 4, you add them. So it's the same as 43 plus 71 plus 83 plus 59 equals, that answer you divide by 4, 64, and it's supposed to be recorded here at the center of those 4 values here. Then you drop the first one, you take now 71 plus 83 plus 59 plus 50, divide by 4. You have 65.75. Now drop 71, take 83 plus 59 plus 50 plus 82, divide by 4. We have 68.5. So drop 83. And now take 59 plus 50 plus 82 plus 93. Divide that by 4, you get 71. So drop that and take 50 plus 82 plus 93 plus 75, divide by 4 is 75. Then we have 82 plus 93 plus 75 plus 62. You divide by 4 is 78. Yeah, 78. Then now you drop into 2, you take 93. You add 75. You add 62. You add 89. You divide by 4. That gives you 79.75. Now drop 93 and you take 75 plus 62 plus 89 plus 101. You divide by 4. You have 81.75. So drop that, you get 62 plus 89 plus 101. Plus 81. You divide by 4. This is 83.25. 89 plus 101 plus 81 plus 73. Divide by 4. That is 86. So 101 plus 81 plus 73 plus 95, divide by 4 is 87.5. So 81 plus 73 plus 95 plus 120, you divide by 4 is 92.25. Then 73 plus 95 plus 120 plus 89, you divide by 4 is 94.25. 94.25. That is what we call the moving averages. Then from there, we now center, and to center, you add the 2 neighboring averages, you divide by 2. So it will be 64 plus 65.75. You divide by 2, and you get 64.875. Then 65.75 plus 68.5 divided by 2 is 67.125. 68.5 plus 71 divided by 2 is 69.75. 71 plus 75 divided by 2 is 73. 75 plus 78 divided by 2 is 76.5. Now 78 plus 79.75 divided by 2 is 78.875. 79.75 plus 81.75 you divide by 2 is 80.75. 81.75 plus 83.25 divided by 2 is 82.5. 83.25 plus 86 you divide by 2, 84.625. 86 plus 87.5 you divide by 2 is 86.75. 87.5 plus 92.25 is divided by 2. 89.875. 92.25 plus 94.25 is 93.25. That is what we call centered. You center like that. The next one is now to get the estimate season loss. And the formula is very clear. What you need to do is to take AU minus T. So 83 minus 64.875 is 18.125. 59 minus 67.125 is negative 8.125. 50 minus 69.75 is minus 19.75. 82 minus 73 is 9. 93 minus 76.5 is 16.5. 75 minus 78.875 is minus 3.875. 62 minus 8.75 is negative 18.75. 89 minus 82.5 is 6.5. Then 1 minus 84.625 is 16.375. 81 plus 86, no. 81 minus 86.75 is minus 5.75. 73 minus 89.875 is negative 16.875. 95 minus 93.25 is 1.75. It's 1.75. We okay? Good. So with that, we are supposed to draw the table for computation of accurate seasonal variations. But because we know we are just going to duplicate some of these figures there, We can then work it from here this way. We go wherever quarter one has a value as an estimate seasonal. So the first quarter one is this one. So put that into the calc, minus 19.75. The next one, which has a value, is this one, minus 18.75. And the other one is this one, minus 16.875. The year total is coming to minus 55. So no. Now, because they are 3, divide by 3. Divide that answer by 3. What you get, you record it in every first quarter. Every first quarter. It is minus 18.4583. We are going to use 4 decimals every first quarter. Then upper there is another first quarter, so record minus 18.4583. There is also another quarter here, minus 18.4583. There is another quarter one here, that is minus 18.4583. That way. Let's do the same thing with quarter 2. Quarter 2, the first one is this one, which has a 9. So same a 9 plus. The next quarter 2 is this one, which has 6.5. So plus 6.5. Plus the next quarter 2 is this one, 1.75. You add them, you get 17. Now divide that by 3. When you divide by 3, you get 5.75. Now record it everywhere we have quarter 2. 5.75. 5.75. 5.75 and 5.75. Then we do the same with quarter 3. So wherever there is quarter 3, this one. So chukua 18.125. Plus there is this one, 16.5. Plus there is this one, 16.375. 51, Divide that by 3. You get 17. Now that 17 recorded everywhere we have quarter 3. So 17, 17, 17, and 17. So we have the averages. And remember now that we have given these as the final answers, we are in the row of the adjusted averages. Now the fourth one, we know it needs to be adjusted. So that because we are in the additive model, the 4 of them should add to 0. So we will take these 3, we add them, we get the value that remains for them to go to 0. So you will say minus 18.4583 plus 5.75 plus 17 equals. Now what you get must now be the value remaining for them to be 0, and it then must come in as negative. So it is negative 4.2917. If you make it negative, now these 4 they now go to 0. So everywhere there is √4, you record minus 4.2917 minus 4.2917 minus 4.2917. Are you okay? Yes. So you don't have to draw the table down there that you normally draw, because we know what is supposed to be done there. You can just do it straight that way. Kama it was multiplicative, then you'd have ensured they add back to 4. So let's now get, now this one, the values we have gotten here are the answers to Roman 1, which told us to calculate the seasonal variations. Now to get the seasonalized, the formula is very clear. It is A minus S. So like the first one, the same as 43 minus 18.4583. That gives us 61.4583. I have 71 minus 5.75 is 65.25. 83 minus 17 is 66. So continue that way until you finish. Then we pick up the next question. So we have finished, eh? Good. Then we can go to question number 2 of that paper. Part A is no longer part of your syllabus, the one that is talking about the game theory. So we go to part B. Part B says Zachem Limited produces two products, namely Alcon and Xenon. The products pass through three departments, namely assembly, finishing, and packaging. There's a maximum of 200 hours in each of the assembly and finishing departments. In addition, the maximum of 400 hours of packaging are available for packing, Alcon, and Xenon. The table below shows the number of hours required per unit of each product. So we are given that each unit of Alcon, Xenon gives a profit contribution of this much. Now we are told to formulate and we solve. We formulate and we solve the linear programming question. So we are dealing with question number 2 now. And the first thing we are told to do is formulation. Formulation. In our formulation, we can argue like this. Let X represent units of Alcon produced and sold. Units of Alcon produced and sold. Y to present units of Xenon produced and sold. Produced and sold. Then objective function. Objective function is to maximize Z. We are already told that the contribution margin of Alcon is 3,000. So 3,000X. And the other one we are told is 2,000. So 2,000Y. 2,000Y. Now this is subject to 2x plus 3y is less than or equal to 200, and this is assembly hours. Assembly hours. That is assembly hours. Then we have 4x plus 2y is less than also 200. And this is finishing hours. Finishing hours. Then we have 5x plus 3y is less than or equal to 400. And this is packaging hours. Packaging hours. Then obviously we talk of x, y being greater than 0, and this is non-negativity. That is non-negativity. That is the formulation. Now the question tells us to solve using the simplex method, but I would want to at least remind you how to solve using the graph. So, Tadika, solution using graphical method. Graphical method. Solution using graphical method. When you're using graphical method, I told you the first thing is to get coordinates. The first thing is to get coordinates. And coordinates, we have this equation of 2x plus 3y equal to 200. Then we have this equation of 4x plus 2y being equal to 200. And then we have this other one of 5x plus 3y being equal to 400. So we have the space for x and y. And we have x and y. X, y, x, y, x, y. Those are the spaces that we need to create. That way. So we say what you do, you say let x be 0. If x is 0, y is what? So you take 200, you divide by 3, that gives us around 67. Then if y is 0, then x should be 100. You do the same here. If x is 0, y is 100. And if y is 0, x should be 50. The next is if x is 0, y is 133. And then here, if y is 0, x is 80. X is 80. Then after that, we now brought the graph. We now brought the graph. So in plotting the graph, I told you you check the highest values. You can see y, the highest is 133, x is 100. See there? X is 100. So we can make a scale. So if I talk of 20, 40, 60, 80, 100, 120, and 140. 140. This is x-axis. X-axis. These are units of alcohol. Units of alcohol. Then this is 20. This is 40. This is 60. This is 80. This is 100. This is 120. This is 140. Then this is y-axis. And these are units of xenon. Units of xenon. Units of xenon. So we just plot now. When x is 0, y is 67. So this is 7 here. So 67 could be somewhere here and 100. So I connect them here. This way. When I connect, I say this is the equation of 4x. No, not 4x. It is 2x. 2x plus 3y equals 200. This other one is y 100 and this other one 50. So my 50 is somewhere here. And my 100 is here. So I have them here. I say this is the equation of 4x plus 2y is equals 200. The other one is y being 133. So 130 is here, so that 3 is somewhere here, and 80, and 80. So this is the equation of 5x plus 3y is equals to 400. And then you shade this side this way, the unwanted region. And you tell us this is the feasible region. Now from there, you can see the optimal corner must be here. This is the farthest from the origin, the farthest. So I don't know whether we are able to read. According to me, they should be allowed 50 or 48. And this other one. Not very clear. It's not very clear because of the. You're getting what and what? Around 28, 25 hapo. Sasa ukianza kusema hapo, that means we are not very clear. And I told you, if you're not very clear, what you do down there now, down there, you solve simultaneously the equations that make that corner. So those equations are 2x plus 3y is equals to 200. Na huyu mwingine ni 4x plus 2y is equals to 200. We solve them simultaneously. So removing x, if I choose to remove x, then what will happen? This one will be 4x plus 3y, sorry, plus 6y, because I'm multiplying by 2 is equals to 400. That way. Then I get 4x here plus 2y is equals to 200. So when you subtract, this gives us 4y to be equal to 200. And therefore, y should be 50 units. Then if y is 50, then I come here and say 2x plus 3 times 50 is equals to 200. So straight on, itakuwa 150. So x should be what? 25 units. X should be 25 units. So if x is 25 units, I'm able now to proceed and say optimal production or optimal solution. Optimal solution. I told you there are two things that will give us when you are talking of optimal solution. And the first one, you tell us production. Tell us about production. And in production, we have alcohol, who was represented by X. That one we are going to do 25 units. We are going to do 25 units. Then we have xenon. Xenon, Y, we are going to do 50 units. So that is the production. Then the second thing you should mention is the profit. Is the profit. And profit will tell us maximum. So the maximum will be equal to, we already know why X we are doing 25, and each one is bringing 3,000, plus this one we are doing 50, each bringing 2,000. So that gives us a profit of how much? $25 times 3 plus 50 times 2 is 175,000 today. Yeah, 175,000. That is what we are going to get. We are okay with that, eh? So I can see time is spent, but let's see whether we can finish using the Simplex method. Using Simplex method. So we'll talk of solution using Simplex method. But remember, in the exam, you just use the method the examiner has asked. I'm choosing to use the tool now because you're revising. So when you are using Simplex, the first thing to say when you change inequalities, changing the inequalities, that is the first step that you take after the formulation. And you say let S1 to be the slack variable for assembly hours. S2 to be the slack variable for finishing hours. S3 to be the slack variable for packaging hours. I told you each of the equations here is given one slack, one S. Then objective function is to maximize Z, which will be 3000 X plus 2000 Y plus 0S1 plus 0S2 plus 0S3. Subject to this one, the kwanza comes in as 2x plus 3y plus s1 is equal to 200. This other one comes in as 4x plus 2y plus s2 is 200. It's 200. Then we have 5x plus 3y plus s3 is equal to 400. That is how you change the inequalities. So we now prepare what we call initial Simplex table. Initial simplex table. And in this table, we say we have a column called C, followed by another one called basis. And here we record S1, S2, S3, CJ, ZJ, and DJ. That's how they follow, because we use these S's. Then we have these three. Thereafter, then we have a column called X. We have another one called Y. Then we have S1. We have S2. We have S3. We have VI. And we have ratio. So this one, I told you, other than these three columns, the C, basis, and VI, these others, they are guided by what we have here, this X given. From there, we record, and in recording, here we record the contribution margins of the items in the basis. So S1 has a 0, this has a 0, and this one also has a 0. Ukikuja hapa kwa S1, ukifuata hapa, you record now these coefficients. So that we have 2, we have 3, 1, then 0, 0, and 200. When you come to this other one, it is 4, 2, 0, 1, 0, 200. The next one is 5, 3, 0, 0, 1, and 400. Then you record the CJs. The CJs are these values in the objective function. We have 3,000, we have 2,000, then zeros that way. ZJ, we say in the initial table, they are always zeros. They are always zeros. DJ is CJ minus ZJ. So this one is saying is 3,000, 2,000, 0, 0, 0, 0. Then from there, we were able to say that now that it is not optimal because we still have some positives, you pick the highest. The highest is this 3,000. So this 3,000, you use its values to create the ratio there. So here I'm going to have 200 divided by 2. That gives me 100. Then I will have 200 divided by 4. That will give me 50. Then 400 divided by 5. That will give me 80. Then we said you pick the smallest. The smallest is this 15. So with that now, you are able to prepare the second table. You are able to prepare the second table. So we are now doing the second table. the second simplex table. Obviously, we have been saying that the titles remain. So C remains. Then basis remains. Then we have X there. We have Y. We have S1. We have S2. We have S3. We have PI. And then we have the ratio, the space for ratio. So from there, you divide the values in the kilo. Kilo is the one we picked here, using the key element. Key element is the value at the intersection, these four. So you say, or before we divide, we need to label here. Now in the labeling, we said this value here at the key column is the incoming. And this value here at the kilo is the outgoing. So S1 will remain, but S2 will be replaced by X. Then S3 will remain. We have CJ, we have ZJ, and we have PJ. So we now divide and say 4 divided by 4 is 1. 2 divided by 4 is 0.5. This is 0. This is 0.25. This is 0. And this is 50. And that one, we call it new row. We call it new row. So when you call it new row, down there in your workings, there is the formula that we use. What tunasema, it is the old row S1 value. You can specify it is S1. We are looking for this S1. Old row S1 value minus new row value times the balancing figure. So the old row S1, you copy the values, which are 2, 3, 1, 0, 0, 200. Those are the old row values. Then the new row values are these ones. We have 1, we have 0.5, we have 0, we have 0.25, we have 0, and we have 50. Then we will multiply by the balancing figure. Balancing figure, we said, is the value at the intersection of the key column and the old row that you're dealing with. So these two. So if I put 2 here, then we said you take the calc and use the formula as it is. So it is 2 minus 1 times 2. The answer is 0. I record it here. The next one is 3 minus 0.5 times 2 is equal to 2. 1 minus 0 times 2 is 1. 0 minus 0.25 times 2 is minus 0.5. 0 minus 0 times 2 is 0. Then 200 minus 50 times 2 is 100. Is 100. So let us do the same for old row S3 now. would draw S3. Would draw S3. So for S3, the values are 5. I have 3, 0, 0, 1, and 400. The balancing figure is the value at the intersection, which is 5. So you put 5 there. Compute those values. So 5 minus 1 times 5 is 0. 3 minus 0.5 times 5 is 0.5. This other one will be 0. Then 0 minus 0.25 times 5 is minus 1.25. 1 minus 0 times 5 is 1. And then 400 minus 50 times 5 is 150. CJ, that remains 3,000, 2,000 and zeros. But for us to get the ZJ, we must have gotten the values in C. The contribution margin for S1 is 0. For X, it is 3,000, and this is 0. Now, I told you what we do here. We will multiply these values in column C with the corresponding values here. And because you can see the first, or rather, this one is 0 and this one is also 0, it means we are just left with 3,000. Yeah, because a number multiplied by 0 is 0. So we shall multiply these values by 3,000 as we record them here. So the first one will be 3,000 here. The second one will be 1,500. This is 0. This is 750. This is 0, and this is 150,000. 150,000. So you subtract. DJ is ZJ minus ZJ, so this becomes 0, 0, 0. Sorry, this is 500. This is 500. This is minus 750. This is 0. This is minus 150. As you can see, we are not yet optimal. So we must design another table. And before we design, we need to identify the highest here, which is the 500. And if it is 500, we get the ratios there by dividing the BIs using the values in that column. So this will be 100, we divide by 2, which is 50. This is 50, we divide by 0.5, which is 100. This is 150, you divide by 0.5, that is 75. And then you pick the smallest is this. So with that, now we are in a position to know who is coming in, who is going away. Sorry, 300. 300, sorry. 300. So we are now doing the third Simplex table. Third Simplex table. 1, 2, 3, 4, 5, 6, 7. So in that case, I have my column C there, followed by basis. So basis, I'm able to tell how it will be because I know this is the incoming. And then because of this, S1 is the outgoing. So I'm going to start with Y here, followed by X, then followed by S3. Then I have CJ, I have ZJ, and I have PJ. I can even fill column C right away. This will be 2,000. This is 3,000, and this is 0. Now I have X, I have Y, I have S1, S2, S3, and then I will have BI. I'm hoping this should be the last one, but if not, you can create a space for the ratio. So with that now, Kasema, what you do is you divide these values using the key element, which is these two. So 0 divided by 2 is 0. 2 divided by 2 is 1. 1 divided by 2 is 0.5. This divided by 2 is minus 0.25. This is 0. And this is 50. That is 50. So we come back here and use our formula. Use our formula again. Now we shall start with odd row X. Odd row X now. Odd row X. So the values in odd row X, they are 1, 0.5, 0, 0.25, 0, and 50. Those are the values in the old row X. Then the new row you have, that is 0, 1, 0.5, minus 0.25, 0, and 50. The balancing figure is this one, 0.5. 0.5. That's the balancing figure. So let's use the calc and say 1 minus 0 times 0.5 is 1. So we record it here. I have 0.5 minus 1 times 0.5 is 0. I have 0 minus 0.5 times 0.5 is minus 0.25. I have 0.25 minus 0.25 times 0.5 is 0.375. 0 minus 0 times 0.5 is 0. I have 50 minus 50 times 0.5 is 25. Good. Let's now get the values for odd row S3. Odd row S3. Odd row S3. So in the odd row S3, the values are 0. I have 0.5. I have 0. Then I have minus 1.25. I have 1 and I have 150. Balancing figure is this one was in a banana. The other one was also 0.5. So 0.5 and the balancing figure 0.5. So putting them in the calc, I will say 0 minus 0 times 0.5, 0. 0.5 minus 1 times 0.5, 0. 0 minus 0.5 times 0.5 is minus 0.25. Minus 1.25 minus 0.25 times 0.5 is minus 1.125. Then 1 minus, that would just be 1. And then 150 minus 50 times 0.5 is 125. 125. Higher. CJ 3000, 2000 zeros. Okay. So I need to show how we are getting the values of Z. Values of Z. These values of Z, Z1. This one, it will be 2000 times 0, 2000 times 0, plus 3000 times 1, plus 0 times 0. And the answer is what? 3000. The answer is 3000. We have here because of the space. When I go to Z2, it is 2000 times 1 plus 3000 times 0 plus 0 times 0. The answer is 2,000. When I go to Z3, it is 2,000 times 0.5 plus 3,000 times minus 0.25 plus 0 times minus 0.25. And that gives us 1,000. No, not 1,000. It's 1,000, that is 250. 250. So the others you can just multiply straight because we already have shown. So hii ingine itakuwa basi 2,000 times minus 0.25 plus 3,000 times 0.375 plus 0 times minus 1.125, and the answer is 625. Haya, huyo mwingine ni 3,000. Sio? Might be the right thing. Oh, it is not even 3,000. It just be 0. And the last one is 2,000 times 50 plus 3,000 times 25. That is 175,000. So when you subtract, this becomes 0, 0, minus 250, minus 625, 0, minus 175. So you can see the table is optimal. Yeah. So you then call it final simplex table. Final simplex table. Final simplex table. Once it becomes final, you then tell us the optimal solution. Optimal solution. Optimal solution. Now, in the optimal solution, we have said there are two things that will tell us. One is production. And in production, we have alcohol, who was represented by X. So what you do, you come to this table that after X, and you run with it to the end, where you get 25 units. Then you do the same with xenon, which was represented by Y. And when you run with it, you get 50 units. Then you come here and tell us profit. Profit, when you run with it, this is the last one, 175. So the maximum is shillings 175. Here it is coming out as negative. You can either write it as negative or positive, whichever you prefer. But most of us prefer positive. Good. In this one. So if we are okay, we have one more lesson remaining, which I don't know whether you need us to meet. You can use it to do your own revision. What do you think? What do you think? We still meet. Those who are online, those who are physical, they are not able to decide. Someone to give me a response. I will go by the first response, either yes or no. Do you still meet? Yes. Good. Then we go by that. Even Sheila is saying yes. Then we meet on Friday. You can see even Esther saying yes. Thank you.